Hello everyone, and welcome to the fifth in a series of webinars brought to you by Tilia Labs. I'm George Follickman, Director of Sales and Business Development for Tilia Labs, and I'm joined by my colleague Tyler Thompson, Global Director of Solutions and Technologies. Today we will be exploring the world of digital corrugated production. I'm excited to showcase our brand new IoT integration with Zund Cut Center, as well as dig into some of the ways that prepress and planning software can directly impact your company's bottom line. We are pleased to be joined today by Heather Roden, Strategic Account Manager for Graphics and Packaging at Zund America. Zund has been a key technology partner, and we appreciate their participation today. Heather, would you like to take a moment to introduce yourself?
Thank you so much, George. Actually, first, I'd like to thank the returning Zoom guests who joined us for the previously held wide format focused webinar. And just kind of let them know that we'll attempt to keep repeats to a minimum, but for all of our new participants, we wanted to share with you that Zund and Tilia both have the same corporate philosophy when it comes to development, and our belief is that open is better. And so serving those packaging providers with an open environment can only help all of us bring the manufacturing of packaging into a future that embraces not only digital, but also Industry 4.0. While Zund's long shared its open API with RIP and workflow partners, Tilia has captured an element of available data from our Zund systems in conjunction with other equipment that makes production planning and estimating more efficient and accurate than ever before. So a little bit on the how of that. Each Zund, which is running Zund Cut Center, has an extensive material database of over 50 materials and their best finishing parameters. Not to mention the multiple custom profiles that you may have created in your own environment. So Zund Cut Center version 2 is where we actually launched the cut times being enabled. So now Tilia is utilizing the Zund Cut Center software generated estimations to give a full view as to how to accurately estimate and production plan. So if you're wondering, how can these estimations be so accurate and not just mere guesstimations? I'd like you to understand that Zund R&D develops their own motors, motion controllers, software, and firmware, often side by side in the same office. So with each little enhancement of those items, the system can be more accurately accounting for in projection of operation, rather than digital cutting technology, which relies on third-party development. So personally, I can't tell you how often I've spoken with packaging providers who shared that they weren't confident that the ROI of digital was going to work for them. And when I was first introduced to Phoenix, my mind immediately went to, whoa, this is finishing analog and finishing digital finally making sense together. So I'm really excited to share this with everyone. Thanks, George.
Yeah, awesome. Thank you, Heather. Appreciate that. So this is intended to be an interactive event. I encourage you all to use the Q&A function of Zoom to ask questions. You can find it at the bottom of your screen. Our presenters will answer these questions in real time or during our Q&A session at the end of the webinar. Without further ado, I'm going to hand it over to Tyler.
Great, thanks, George. Just want to confirm you can hear me and I'm not muted.
Yep, we can hear you, Ty.
Excellent. All right, great. Well, thank you everyone for your time. Thanks for joining. Good morning, good afternoon. We have quite a few attendees spanning over about, 12 countries. Wow. So as George mentioned, I'm Tyler Thompson. I'm the Solutions Director here at Tilia Labs, and I'll be hosting the webinar. So a little bit about myself. I've been in the industry, printing and packaging industry, ever since graduating from Clemson University, where I hold a Bachelor's of Science degree in Graphic Communications. I'm based in the beautiful state of South Carolina, and I also hold a master's degree in Computer Information Systems from Denver University. If you have questions or comments, feel free to reach out. My email is below, tyler@tilialabs.com. Or as George mentioned, you can use the interactive Q&A features inside of Zoom and chat us over questions as you think of them. So just an overview of what we'll be talking about today. I'll start with an introduction of Tilia Labs. So any of the attendees who are new to Tilia Labs, we'll give you just a brief introduction of who we are. Then we'll move into what is Internet of Things, what is this whole concept of IoT, and how is it being used? And then we'll introduce Tilia Phoenix's nesting capabilities and include a demo of our new IoT integration, specifically with Zoomed Cut Center. And then at the end, we'll leave about 15 minutes for Q&A. So either, again, answer or ask your questions throughout this webinar, or you can save them till the end where we'll open it up for more Q&A. So a little bit about Tilia Labs. Tilia Labs, we're a software company, and we're only a software company. We're not attached to any specific hardware, nor do we manufacture any hardware. We partner strategically with hardware manufacturers to connect to their devices and help with estimation and production planning and positioning. So Tilia Labs won the Intertech Award in 2019. So just this past Intertech Award for our true AI technology, which is what we'll talk about and focus on today. And our company, Tilia Labs, was founded in April of 2012. So we're relatively newer to this particular printing and packaging space as a software company. And we're based in Ottawa, Canada. We have a team of developers software developers that sit in Toronto, and we have a team of developers that also sit in Tokyo. So we're a small, highly skilled group of developers that are excited and anxious to continue growing our customer base in this industry. And we've grown really quickly since 2012. So year to date, we have just over 500 licenses sold. You can see our customer mix to the right is primarily packaging and labels, but we're quickly growing in the sign and wide format and commercial space. And for those of you outside of the US where I'm based, we have global distribution partners in over 32 countries. So again, if you have questions or need to get in touch with the distributor, just feel free to reach out to myself or info@tilialabs.com, and we can get you in touch with the right person. So we'll focus on our product, Tilia Phoenix, which is our flagship product. But we also have, you'll probably see on our website, two other subset products of Phoenix, which is Tilia Griffin, developed specifically for digital sign and wide format. It's a subset of Phoenix, and we've got webinars coming up on Griffin in the future. And Tilia Aries is also a subset of Phoenix. It is a digital label step and repeat software. Also, we had a previous webinar on it. And then Tilia Cloud is our cloud-based licensing platform, which all of our software products are able to be, the license is able to be shared and floated so that multiple users can use a license. So let's dive into it. What even is IoT, or Internet of Things? Well, it's being used around us every day, and we're using it in our personal lives every day. And the whole concept of IoT and Internet of Things is just really to connect a device to the internet to make your life easier. And if you take, for example, Alexa, you can speak to Alexa and add something to your shopping cart or to your to-do list, right? Instead of grabbing your phone or writing it down on a piece of paper, it makes your life easier. And in my case, my refrigerator is connected to the internet via IoT and is constantly weighing my gallon of milk. And when my milk hits a certain threshold of weight, my refrigerator simply reaches out to my grocery list and plops a gallon of milk on my grocery list. And we see IoT also being used in home security to protect our loved ones and to, well, introduce cameras to the internet so you can see who's knocking on your front door. And if we see IoT being used, every day in our personal lives, why don't we see this translation into our professional lives, into manufacturing? Well, we do see it. In fact, we see it being used more and more every day. For example, in pharmaceuticals, track and trace is being used to properly prescribe pharmaceutical drugs and to properly ensure that consumers are consuming the pharmaceutical drugs properly. And we see this, in John Deere's example with, leveraging IoT to drive the tractors in crop fields to have less human touches or less human interactions to manage and grow our crops. And another really interesting one is IBM with their safety wearables, where IBM partnered with a steel company with wearable technology so that they're tracking the location of a human to automatically enable and disable dangerous machinery. So we do see IoT being used. We see these devices connecting to the internet, not only to make our lives easier, but also to, in IBM's case, save people's lives. So how do we then, take IoT and make this applicable in printing and packaging, specifically in digital corrugated? And what we've done is we've taken this concept or this manual process of estimating and planning and applied AI and applied IoT to make this process easier. What we see is, this process of estimating and planning is typically a manual process that's being done in the likes of Adobe Illustrator, or in some cases, we have customers which are physically cutting out these items at size and trying to place and, nest them up on a sheet to see how many can fit. So it's very kind of manual process of estimating and production planning. And to make it easier, a lot of times we're just basing it off of the bounding box of the shape or the lay flat of the shape and using some rough, machine speeds to quickly calculate the number out on a sheet and how much material and how long is it going to take to finish. And this process can take hours or in some cases days to estimate or plan a job. And because of that, we're typically planning one job at a time, or a human is only looking at or evaluating one job and planning one job or estimating one job because it's a much simpler process. So if we take a look at what this looks like, we can take a simple e-commerce job as an example. So in this scenario, we've got a quantity ordered from our customer of 500 of this e-commerce printed box. And what we need to figure out is, how many up are going to fit on our 60 by 120 inch board, and how many sheets is that going to take, and how long is it going to take on press, and how long is it going to take to finish? And what we're typically doing is looking at the outer bounding box and doing some rough math. So if we take a look at that 15 by 18 outer bounding box, you'll see that we get 18 up, if you did your math quick, 18 up, and it's going to take us 28 sheets to produce our quantity or to achieve our quantity of 500. And if our press is running at about 25 beds or 25 sheets an hour, it's going to take us a little over an hour to finish this, to print this job. But then the question is, how long is it going to take to cut this job? And again, this is typically done in a more or less rudimentary kind of manual estimated process, right? It's, well, let's evaluate the complexity in many cases of the box. And it looks like this box is fairly complex, so we'll assign 10 inches per second of time and about a minute per board to manually feed and offload the cutting table to finish. And doing some basic math, we can conclude that it's going to take us an hour and 7 minutes on press to print, and then another hour and 15 minutes or so to cut. And this is typically the process that we're seeing in the industry to try and estimate or plan production for our digitally printed and digitally finished jobs. However, what ends up happening is we don't use bounding boxes. We nest because we want to try and minimize the amount of material. So we end up interlocking our boxes, and we go from what we initially estimated at 18 up was our estimation, and we actually got 24 up on a sheet. So we netted in that case 7 boards with our actuals, and then our time on press, we actually decreased the amount of time on press because we decreased the number of boards we had to print. However, in finishing, we ended up being way under on our finishing estimation. So we estimated about an hour and 15 minutes, but it ended up taking us in our actuals about 3 hours and 15 minutes to cut, right? So this process of trying to figure out how long finishing is going to take is an extremely challenging problem in its own. And you can see if we attach a cost to this at an industry average of about $280 per hour for your equipment, well, sure, we estimated our board and board consumption and our time on our digital press pretty well, but we lost about $560 on this simple order of just 500 digitally printed e-commerce boxes. So it's very costly to be wrong in these scenarios. And then the problem gets even more complex when we start adding additional materials, additional quantities, right? And more SKUs to try and manage or try and estimate and plan. And the reason it's so challenging is because there are so many variables in what we're doing, especially with digital finishing. Every single job that comes through our shop is custom. It's a custom shape, it's a custom size, it's got custom finishing, it's got custom print, right? We have different stocks and different equipment that we can run it on, right? When you look at adding up all of these different possible combinations of ways of running and comboing your jobs and planning your jobs, it becomes this astronomical number to comprehend for a human. So why is this important? Well, packaging trends in general are beginning to become more and more proliferated. So the number of SKUs in many cases aren't shrinking, but rather growing, right? It's not just 1 or 2 different types of Cheez-Its, it's 35 different flavors. And we see this happening not just in primary packaging, but also secondary packaging. So, we need promotional products, we need promotional POP displays, they need to be very short runs. So the brand owners are challenging now the printer converter with these shorter runs, an increased number of SKUs that you have to plan for production. And while you're doing this, you need to manufacture this for the brand in faster turnaround times, and you have to somehow then try and figure out how you can decrease your cost all at the same time. And this is becoming an extremely large bottleneck in many cases when you're trying to manually plan your production. So this is where we've introduced our AI technology and IoT integration with Tilia Phoenix. So Phoenix is the industry's first IoT-enabled estimating and planning algorithm. And what we do with Phoenix is we give and integrate with Zun's Cut Center to provide the printer converter with this IoT enablement and cost estimation at their fingertips upstream in the estimating and planning process. So let's take a look at how this works. There's three basic steps here that I want to highlight. The first step is focused around the Zune Cut Center. So Zune Cut Center has a material database of over 50 plus materials and parameters for cutting. So the material database is a pre-built and predefined database of settings with optimized cutting settings that are pre-baked or pre-built into the Zune Cut Center so that the customer can immediately get started and can immediately have access to optimize cutting parameters for their different materials. Furthermore, the Zune Cut Center comes with a highly accurate motion control simulation, and Zune Cut Center exposes their open API architecture for connectivity to a third party. So what this means is that when Phoenix is running and estimating your jobs inside of Phoenix, you can now connect directly to your Zune and your Zune Cut Center by adding a device inside of Phoenix, pointing to your Zune Cut Center IP address, and you will gain a connection to the Zune Cut Center, which allows this connectivity between your imposition tool, Tilia Phoenix, and the Zune Cut Center, which allows Phoenix to then start building the nested layouts based on the quantity in the material, send that information over to Zune via IoT, and consume that information of how long it's going to take to cut and finish right back into the user interface so that you can quickly estimate and plan your production in an efficient and cost-effective and speed-effective manner. So this is, Tilia Phoenix is again, the industry's first IoT-enabled imposition and planning tool on the market. So let's take a deep dive in how Phoenix is working. So we'll start with a digital corrugated planning demo where we're looking at sheet nesting optimization. So inside of Phoenix, what I'm going to do is I'm going to start by importing a list of orders. And this list of orders is coming directly from my ERP system. So in my case, it's a FileMaker, but this could be any order entry system, which contains a list of your orders. Let me back up a little bit. A list of your orders, your order quantity, the material that this order was, that your customer ordered on, and your min and max overruns that you've allowed for this particular order. And what I'm going to do is I'm just going to open this order sheet right inside of Phoenix, and Phoenix is going to go grab all of the artwork files. In this case, it's a POP multi-part display. So it's got a shape to it. You can see Phoenix has detected the shape based on the die lines in the PDF file. And what I'm going to do is now ask Phoenix to plan and impose the job and nest the job on my wide format digital press. So I select all my presses. I've got two different material sizes, and I click go. And now what Phoenix is going to do is run its imposition AI nesting algorithms to nest and optimize the sheet for the best material consumption and present to the end user with many different results. There is an infinite number of ways to nest these 64 different items on across several boards with their quantities taken into consideration. And what Phoenix is going to do is continue to pack and nest and reduce costs by reducing the number of sheets to be printed on and reducing the amount of, in trying to optimize the cutting based on the information coming from Zune. At the same time, once you're satisfied with the result, Phoenix is going to add all your production marks. It's going to add the barcode, the registration dots on each form, on each sheet, and then send this information down to your, send the high-res imposed PDFs to your printer for your RIP, and send the cut files directly to the Zune, which includes the cutting lines, the registration dots, the copy count, and barcodes for Zune to start the process of cutting in an automated fashion. So if you noticed on that last demo, Phoenix mixed, it tried to produce the most cost-effective plan, right? And it mixed your orders together on the same sheet. What I'm gonna do now is, you can see I'm gonna pass another column here, or a property, for each one of my components of my multi-part display. So in this case, you can see job 1 is comprised of these first 6 components here of the display. Job 2 starts where my mouse is here, and it's got another 6 components of the multi-part display, different artwork. So now what I want to do is, instead of mixing all of my items together, where Phoenix is trying to optimize material as much as possible, I want to try and optimize now my handling. So when I am pulling my orders off of my finishing equipment, it's coming out in an easy kind of consumable way for your users to pick it off the table, to pick it off the die cutter, so that they can palletize and ship and pack these items to be shipped to the store in a more efficient manner. So what I'm going to do, you can see inside of Phoenix, is I'm going to add a simple rule here where I can pass a really any parameter that's sent over on the order. In my case, I'm just going to show a couple examples of what our customers are doing. So I can, for example, pass over the zip code of the order and group things by zip code, so that they're, I'm not mixing zip codes with other zip codes, or maybe I've captured the store name from the order, and I want to keep all of my stores together when they're coming off the printer and off of the cutter. So, in Phoenix, you can add this really infinite number of rules to anti-mix or keep, your orders in groups to make it more efficient coming off of your finishing equipment. But in my case, I'm just going to keep it sorted by job name, because I just passed the job number for each batch of orders here. And you'll see now Phoenix will quickly, in a matter of seconds here, start generating hundreds of results. And when I apply this result, you can see it may produce, more cutting files and more print files in this case, but you can see it's now grouped together, all the reds with the reds, and it's keeping my jobs grouped so that when it comes off of the finishing equipment, we can pack, palletize, and ship these out more efficiently. So now what we're going to do is run that same job, and I'm just going to highlight here the IoT integration. So again, I'm just dragging a CSV file right from my business system into Phoenix's user interface. Phoenix goes and grabs all of the orders, adds the quantities of the orders and the material. In this case, I'm going to select all my products, and you can see I'm now introducing my Zune G3 because I want to estimate this job and see how long it's going to take to cut. When I run the job, Phoenix is going to run and start optimizing the results like you saw before. But as we start generating these different permutations, you can see the pending up here for cutting time. You're going to see that pending start to disappear, because that means we've got the IoT feedback from the Zune Cut Center, and it's estimated our cutting time and confirmed by Zune. So as we're generating these results, there we go. You can see we're sending all of these permutations down to Zune Cut Center. We're getting responses back from the Zune Cut Center to tie and correlate that back into a cutting time into Phoenix, which then allows us to add costing and cutting costs to the job, so that we get this kind of immediate ability to estimate and understand not only our print costs, but also our finishing costs in production. So once we're good with one of those results, I'll just skip forward here a bit. We can go through each layout, and you can see we're going to get a breakdown of how long each layout is going to take to print, what's the copy count, and how long each one of those boards is going to take to cut on the table. And then all that information is sent down through the ZCC file to automate the cutting and to automate the material selection on the Zoom Cut Center. So you can see we're adding the specific Zoom QR code for automated board feeding if you have an automated board feeder. Or even if you're manually feeding, you can just scan the barcode to grab the correct cut file, and then you export your ZCC file directly from Phoenix right into the Zoom Cut Center. Okay, then the last thing we'll do, and then I'll wrap it up with a Q&A. But now we want to look at a quick demo where we can evaluate conventional die cutting and evaluate that cost against digital finishing. So in this case, I'm going to grab those mailers that we saw earlier in the presentation. And part of the device setup allows you to introduce costing for your digital press, for your digital ink costs. So if I back up a little bit here, you can see we can include on my Nozomi, in this case, a coverage calculation, and you can model your ink costs inside of Phoenix. So it allows not only to figure out how long it's going to take on press, but also can give you an idea based on coverage of how much ink is going to be consumed and attach a cost to that. And in this case, I've got a flatbed die cutter. So I've got my BOPS master cut here. I can attach costing, setup time, machine capabilities, min and max sizes. And then I've also got the ability to model my costing to actually build a physical die. So Phoenix not only understands running a press, running a die cutter, and running a digital finishing table, but you can actually model your costs based on linear inches of rule and attach a cost to your rule length. So you not only understand if it's more cost effective, Phoenix can look at, what is it going to cost if we digitally print and digitally cut this order. So that's what we're showing here in this case. Give it a second to, there we go. So now we get our cutting time back from Zoom. So 29 hours to cut this. This is a pretty large job here. We've got 230 sheets here on our Zoom G3. And then what we're going to do is we're going to take the same job. So it's about $6,000 to run it this way. We can take this same job now, and we can figure out what it's going to, that's if we estimate and run those items single out on a sheet. Now we're going to combine those orders on the same sheet to reduce the amount of print and reduce the material consumption. So we went from an estimate, now we're comboing these items on the same press run, and you can see we're going to save about 9 sheets of corrugated material there. And now what we're going to do is simulate the cost if we were to create a die and run these on our digital printer and die cut them on our flatbed die cutter. So if I back up just a little bit here, you can see that if we run these single item per sheet, meaning we create a die for each design, each mailer here, it's going to cost us about $10,000 to build the die, to run the die, and to print. And then we do one more simulation where we actually create a single die of these items mixed on one die, kind of a build the die and throw it away scenario. And you can see just the setup time and cost that's reduced here, right? Because we don't have to, now we go from 3 setups on our box down to 1 setup. We go from 3 dies down to 1 die. So this, what Phoenix allows you to do is quickly simulate these different scenarios and evaluate the cost of running it on a flatbed die cutter and modeling your die creation costs, as well as evaluating what it would take and what it would cost and how long it's going to take to finish these on a table versus on a die cutter. All right, so just to wrap it up here, a few of the high-level benefits. Again, Phoenix allows front and back recto verso nesting, tiling, quick, ability to import CSV data from your ERP system. The direct IoT integration with Zune for cut time and finishing estimations, and the ability to compare die cutting costs versus CAD cutting, and evaluate the time and cost in doing those two different finishing options. And then I'll just end it with the corrugated use case. So one of our very good mutual customers with Zune and Tilia Labs, as well as the FI, is Advanced Graphics. Advanced Graphics, I just want to highlight one interesting comment that they made in the Pack World article. Because it's so efficient at fitting artwork into a file, it reduced the number of corrugated sheets required for a given print run. So what was taking, in this case, Advanced Graphics, 600 sheets in the past is now taking them only about 400 sheets because of the ability to eliminate a human from, manually nesting to using AI and using a machine or using software to optimize the material. And with that, George, I will open it up for questions.
Awesome, Tyler. Thank you. That was a really, really good presentation. We've got a bunch of questions coming in, and I want to thank you all for asking them. If you also have a question, feel free to throw it into the Q&A there at the bottom of the screen. Tyler, we had a couple questions come in. The first question is this. The Zune integration is fantastic. Does Phoenix integrate with any other cutting tables besides Zune, and can we get costing information from any other cutting tables?
Yeah, so our IoT Enablement, our first partner with IoT Enablement is Zune. So today, the only device manufacturer that we're integrated with is Zune Cut Center. And Heather, you'll have to correct me if I'm wrong, but I believe it requires Zune Cut Center 3.0 and above. Could be mistaken. So the other option with estimation is when you add a digital finishing cutting device. Tilia Labs has an estimation engine where you can come and model your different settings to kind of simulate more or less what a laser cutter or a CAD cutter would and how it would perform, right? And you could set this up with different stocks. So for different stocks, you could set your, some basic, velocity and accelerations. We've built a physics engine in here to, more or less model and estimate what how a cutting table would perform. But when it comes to IoT and this true cut time estimation, Zune is our partner, cutting table partner.
Awesome, Tyler, thank you. We had another question, and Heather, I'm going to let you answer this one. But we had a question about the material profiles in Zune Cut Center and whether or not they can be customized or optimized. Yeah,
actually, absolutely, George. They can definitely be customized. Every environment has maybe a different corrugator, and so what they see as the best parameters for cutting can definitely be utilized. Certainly in packaging, we very often see that there's the usage of one of our key features that with a simple click of a radial button, you're going to change any corner points into a radius. And this vastly speeds up cutting time because you're no longer stopping at a corner, picking up and turning. You're actually just winding right through that area. So definitely customized material is enabled.
Awesome. Thanks, Heather. Tyler, another popular question here. Got 3 or 4 people asking if Phoenix integrates with other MIS systems or workflow systems. Yeah, is there any kind of integration or workflow component with Phoenix?
Yeah, so with Phoenix, there are a handful of ways to integrate with business systems. So what I showed in the demo was the ability to import a CSV file. So when you're importing a CSV file, Phoenix can then quickly map that data into product information. So it eliminates, it's definitely the most simple. It comes with Phoenix out of the box. Easiest way to pull information and just drive Phoenix with that data through CSV. The other way is, well, there's a handful of other ways. We have a RESTful API. So everything that we showed you in the demo and virtually everything that Phoenix can do in the user interface has an associated REST API, open API architecture. So if, this allows you to do any of Phoenix's capabilities headlessly. And we also have, for any of our customers who have Switch or really any other workflow system, we have the ability to use Phoenix through hot folders. We have a pre-built Switch connector to drive it with Switch variables. And then, like I said, through hot folders, XML or CSV, or just dropping PDFs into hot folders so that you can automate it. And then exporting, George, I guess the other half of that question. So if you are using Phoenix for wanting to export your results into another workflow, you can export JDF information. So the results of Phoenix can be exported as JDF. Which can then be submitted to really any workflow system at that point to do the handle the impositioning or trapping or any other components that are needed for file preparation.
Awesome, Tyler. That's great. That answered a couple questions as well. So appreciate that. Here's another really good one. So we've got someone on the call here who is challenged with estimating. Typically in the estimation process, there's no artwork yet, but maybe just like a die design. Are we able to add, for instance, like certain inks and certain like a coverage percentage or something to drive to an estimated, or to drive to a quote? Yeah,
that's a really good question. So we did a folding carton demo or webinar just, I don't know, a week or 2 weeks ago, George. It's on, I think it's up or will be up on YouTube eventually. But in that folding carton demo, we showed this scenario here. So you can see this is a CSV file. And in this case, I don't have any artwork, but I do have the CF2 die line structural file, the CAD file. And over to the far right column is the front inks for these items that are specified. So you don't need artwork. As long as you have the shape or even just the dimensional information, you can see Phoenix will consume all that information and then allow you to either generate your dies single out. So you can see there's building die lines single item per sheet, so just multi-out dies, or of course going and optimizing in rows or comboing these as efficiently as possible for digital cutting or even generating dies, combo dies like you see here. So yep, it can be done with or without graphics.
Awesome, thanks. And I'll apologize to all of our corrugated listeners who hate seeing folding carton up on the screen. I think we've been yelled about that before. So cool. Yeah, no, but you answered the question. So thanks, Ty. We got a bunch more here, and I know we're running out of time. I want to be respectful of everyone's time. So if you've got more questions, the ones that weren't answered today, I'll try my best to reach out directly and answer your questions. And if you continue to have questions, of course, reach out to us. Yeah, so I want to take a second to extend a big thank you to Heather for jumping on with us today, and of course I want to thank all of you for taking the time to join us today. It was really our pleasure. Be on the lookout for a follow-up email. I will send out a link to the recording of this presentation. I encourage you to share it with your colleagues or share it on social media. It'd be really great. Also, just as a reminder, this is the 5th webinar in our educational series. Up next, we have a commercial print webinar. You can sign up for that at sales.tilialabs.com/events. And you can also jump on YouTube. We're posting all of our previous webinars, as well as some short demonstration videos that kind of get straight to the point. So go check that out on YouTube. Thank you, everyone, and have a great rest of the day.
Thanks, George. Thanks, Tyler.
Yep. Thanks, Heather. Thanks, everyone.